Good morning, Algebra 2, and welcome to another exciting lesson. Here we're going to find some slopes and rates of change. Rates of change is just a fancy way of saying slope, but in some sort of applied setting. So right here, our first little exploration thing is in the Mojave Desert. Temperatures can drop very quickly from day to night. Let's suppose the temperature drops from 100 degrees at 2 p.m. to 68 degrees at 8 p.m. Find average rate of change in degrees per hour. So that tells me that the change in degrees has to go on top, degrees per hour. So that tells us top and bottom. So degrees, we're going to take 100 degrees minus 68 degrees over 2 p.m. to 8 p.m. So the change in time. It was supposed to be an 8. Okay, and if we take 100 minus 68, we should get 32, and this is negative 6, right? So we would have 32 divided by negative 6 is a negative 5.333 degrees Fahrenheit per hour. Okay, so that negative just means that it's dropping, of course, and 3 decimal points is a really good way of rounding in Algebra 2, so let's go ahead and just use 3 decimal points when necessary. Now, if it's going to drop 5.333 degrees, about what temperature would it be at 10 p.m.? So we're going to take off another, 2 hours of time, so 2 more iterations of that decrease. So if we take 68 and we subtract 2 times the 5.333, we would get something like 57.334. So it's going to be about 57 degrees Fahrenheit at 10 p.m. Okay, so we can make predictions based on the average rates of change. Sometimes. So slope, officially, you've talked about slope many, many, many times. This should not be new material, but worth repeating because it is so incredibly important. So slope is the ratio of vertical change to horizontal change. We've talked about slope as rate of change just now with the desert example. You've probably talked about it quite a bit as rise over run. And also remember that there is a slope formula, okay? The change in y's over the change in x's, so y2 minus y1 over x2 minus x1 is definitely a formula you need to have memorized. Okay, so vertical change over horizontal change is how we do that. So if we're going to find the slope between these 2 points here, I'll do the first one and you can do the second one and check. So I'm going to take y2. Some people really like to label these. If it helps you, go ahead and do so. So I'm going to take y2 is 7 minus 3 over 4 minus 2, and I'm going to simplify. So you have 4 over 2, which is 2. So slope is 2 here, right? Now you go ahead and try this second one here and see if you get the same thing. I do. So I'm going to take negative 3 minus 15 and 5 minus 2. So we get negative 18 over 3, slope of negative 6. All right, which of these lines would be steeper? If you said this one at negative 6 slope, you are correct. The larger the number, whether it's positive or negative, the larger in absolute value, the steeper the line. So that line, that second one, would be a steeper line. Okay, 4 types of slopes that we look at. We always take into consideration that we read our graphs from left to right. So a positive slope would be increasing as we read from left to right. Negative slope is going to be decreasing as we go from left to right. It looks like it falls. A zero slope is just very constant. It's a horizontal line. And then the super fun kind is undefined slope. Vertical lines have undefined slope because division by zero is not allowed. So keep those in mind as you're talking about these examples and working in your homework. Other things to remind you about: parallel lines have exactly the same slope. Okay, so two parallel lines, you have a blue one and a purple one here, same exact slope. If one of those is a slope of 1, so is the other one. Perpendicular lines have opposite reciprocal slopes. Opposite meaning one positive, one negative. Reciprocal meaning something like one of them has a slope of 2, like you see here, and the other one would be the reciprocal, or 1/2. So negative 1/2 and 2 would be perpendicular. And of course, from geometry, you remember that that little symbol of box means 90 degrees. All right, and here's some more rates of change just for practice. So the population of Fargo in 2000 was about 91,000 people. By 2017, the population had increased to 122,000. What is the average rate of change? So we're going to take and have the population change on top. So 122,000 minus 91,000 over change in time, which is 2017 minus 2000. Okay, some quick calculator work. This would be 31,000 over 17. So about 1823, and 3 decimal places is 529 people per year. So that means the population of Fargo was increasing, because it's positive, at about 1,823 or 24 people per year. Because this is talking about people, we probably do normally refer to that as 1824 people per year, or 1823. It wouldn't be wrong either way. Decimals just don't make sense when we're talking about people. The grade of a road down here, not super important, like common in Fargo because everything's flat, but the grade of a road is the horizontal, or the slope represented as a percent. So horizontal distance covered in this road, or in a road, is 5 miles, horizontal 5 miles. Vertical change is 0.3 miles. What is the grade of the road? So again, slope is rise over run, so vertical change 0.3 over horizontal change of 5. And if we take 0.3 and divide it by 5, we get 0.06. Now, the grade, like you see on these types of signs, if you've ever seen them, the grade has to be written as a percent. So what is 0.06 as a percent? This is a 6% grade. Okay, hopefully you found some of this helpful, or at the very least just reminded you of something you already know. Let me know if you have any questions.